Okay, YouTube, in this video we're going to continue our exploration of graphing linear inequalities, but what we're going to focus on is essentially this idea that we could graph linear inequalities without having to use a test point in specific situations. So the very first two situations that I want to basically recognize is that if our function is in y equals mx plus b form or slope-intercept form and we have an inequality, then it says that we could graph inequalities of the form y is greater than mx plus b or y is less than mx plus b without using test points by using the following thing here. It says that if y is greater than mx plus b, then we're going to shade the half plane above the line y equals mx plus b, and if it's less than, then we'll shade below this. And so just kind of to basically illustrate this here, if we said y equals, how about 2x minus 1? Now, of course, I know that this would have a y-intercept of -1 and a slope of 2, so it rises 2, runs 1 here. But you could see that if we were to change this equals to instead a greater than, okay, let's do this, greater than, then you can see a couple things here. First of all, I hope you can see that they put a dotted line here, and it's the same as the line y equals 2x minus 1, but we shaded above. And so because that's greater than, we shade above. If this were less than, we would shade below. Okay, so that's one thing we want to note here. If it's in slope-intercept form, then we can really kind of cheat and look at this leading sign here, or I guess inequality sign, to determine whether we shade above or below. Now, it's also not necessary to use test points when you graph inequalities involving half planes or on one side of a vertical or horizontal line. So we would say that when it comes to vertical lines, these would be lines given by the equation x equals a. Okay, recall that if we were to type in x equals a number here, let's see if it'll let me manipulate this like x equals a. We could say, well, apparently it thinks I mean something by a. Let's take that out and try this again. X equals a. It won't let me put in a slider for this, but that's okay. If I put in this here, you can see that basically this is a vertical line at that x value for which we're saying x is equal to. And if we were to do the same thing with y equals, like y equals 1 here, you can see that we would slide above or below. So the thing we basically want to recognize here is this. If you're talking about, say, x is, say, greater than 1, then really you would graph the line x equals 1, but as you might, assume, as you go to the greater than values, or values greater than 1, we would shade to the right. So if it's greater than with the vertical line here, then we'll shade to the right. If it's less than, we'll shade to the left. And likewise, when we talk about horizontal constraints, if we say greater than, we mean shade all the y values above. If we say less than, we mean shade all the y values below. So to talk about graphing these pretty easily, we'd say that a vertical line, x equals a, if x is greater than a, we're going to shade the half plane to the right. If x is less than a, we're going to shade the half plane to the left. And we can see this down here in this region. So we say, here's our x equals a, and we'll shade to the left if x is less than a, shade to the right if x is greater than a. And with horizontal things, we would say y equals some y value b. We would say if y is greater than b, we'll shade up here in the green. If y is less than b, we'll shade down here in the yellow. So what I want to do before tuning out of this video is basically graph some horizontal and vertical constraints or inequalities. So looking at this here, it says graph each inequality in a rectangular coordinate system. Well, y less than or equal to 3, the very first thing we do is replace that inequality with an equal sign, and we go and graph this line. So now knowing that it's a y equals a -3, essentially we're graphing the line having a y value, or all of its y values at -3. So if I go down 3 here and I go straight across, the first question I've got before I sketch this in is, should I use a solid or a dotted line? So because this is an or equals to, we're going to use a solid line. Let's see if I can get it to go through -3 here. Huzzah. And we're going to label this y equals -3. Now in terms of shading above or below, because it's less than or equal to, then I know that what we're going to do is we're going to shade this entire half plane below here. And so we'd say all the points on this line and below this line are solutions to this inequality. Now for letter B, of course letter B, when we look at it, it is an x is greater than 2 type of inequality. And so when we rewrite this x equals 2, again, we get a vertical line this time. But we would have to check to see if it's solid or dotted. And so I noticed that because it's just greater than, this is going to be dotted, but we still label this with the equation here. And we'd say if I'm going to shade left or right, depends upon this sign right here. Well, all x values greater than 2 would lie to the right side of this. So I could scribble in the whole right side because I want you to get into the habit of doing this later on anyway. So let's go ahead and do this. We say that shading to the right would provide us with all the solutions to this inequality, but none of the points actually on this line would make this original inequality true. So what I want you to do is go ahead and sketch these horizontal and vertical constraints down here, being mindful of solid or dotted lines, but then also label and shade the half region that contains the solutions. Cheers.